Okay. It's been a while since I started working on the this injection mold. As I started to get close, I had this guy here, which had an open design here. This was kind of a failure and unnecessary, and this got stuck to the vat and got kind of ripped apart towards the end of the print. It's a time-lapse video of this if you want to take a look. But you can see that it's started to get looking like what it should be. Then this guy here, which came out yesterday, back to the two-hole design, which is good, but the separation forces kind of got this warped. And I had a bit of trouble, right? I have a bunch of, you can see there are some lines here where the supports are, and I probably could have gotten this orientation to work, right? There's a bunch of supports here. This is at a 45 degree and then a 10 degree angle. Probably could have gotten this to work, but it was a little bit mysterious exactly how thick I would have to make the connection points here or whatever. So I tried for a completely different tack, and that was direct to the build plate here. Now, you would normally think that making something this big, right, against the build plate would be impossible. Even though this is shelled out and hollow, it's shelled to 2.5 millimeters. So the shell is pretty thick, and there's still quite a lot on the top, and there's a bottom here. And so how did this work? There's some magic. And the magic is not very magical. I printed it directly on silicone. Now, printing it directly on the silicone vat, direct silicone vat is a lot less sticky than any of the films on top. By a factor of 2, maybe as much as a factor of 10, enormous amount. Huge difference between printing on silicone and printing on the FEP, on the film. But silicone is way more delicate. So you look at the silicone, you see there's kind of this impression here, and what you're seeing here is some of the failures, the supports from this guy here. You're seeing the shape of the part that I just printed here. And what happens is when you print DLP on silicone, there is the curing reaction affects the surface of the silicone, and it causes it to get cloudy. And this cloudiness will show up as a minor surface aberration on your part, which isn't so big of a deal here, since this is a structural rather than a cosmetic part. What will also happen is if there's a part that gets really stuck on, it will, instead of, say, if it gets really stuck on, maybe you pull it up enough and it might pull the film off or something. In this case, it'll tear a chunk out. You'll see here, it tore, somewhere in the middle of the print, it tore a chunk out of the silicone at the bottom here, and that did affect the rest of the print. If we look closely, kind of over here, there's a surface aberration here, and this surface aberration right here is the same shape as the chunk that was torn out. And so basically that causes a raised spot here, because when I cure these layers, that section will cure extra thick because the silicone has a chunk torn out of it. I'm going to have to sand that down, but otherwise this turned out structurally pretty good. Printing it flat means that at least the top surface and the bottom surface are pretty flat. There was some warping, and the warping did create some undesirable side effects I'm going to have to manually fix up. My intention all along with the shelled part is to fill it with epoxy. So I sit this down, fill this hole until this hole shows epoxy coming in, all done. I can use the casting grade slow cure epoxy. The separation forces in the corners right here cause there to be a hole. I noticed this when I was filling water in here. I noticed that water was actually coming out of this corner here. There's some other surface aberrations here that look like tears, but those don't seem to have gone all the way through the 2.5 millimeter thick wall. Here's the only part where I seem to have lost something. We also notice that there is some kind of aberration, maybe overcure or something, all the way up to this level here. And if I grab the calipers, that goes up to about 5, 6, 7, 80, 8.7. So that's layer 87-ish. Which is actually right about where I switched from 6-second exposure to 5-second exposure. So it seems like for 0.01 millimeter layers, the right exposure for this fun to do resin is 5 millimeters, 5 seconds rather, and not 6 seconds. And so I probably need to do attachment layers, thicker of course, and then quickly drop down to 5 seconds as probably the ideal exposure time. One of the ways, besides the printing directly on silicone, another way that I managed to avoid having the whole thing tear apart while printing is I had the lift speed set slow the whole time. So I need plenty of lift. I go from 8 millimeters rather for the attachment layer, and 7 millimeters up the rest of the whole thing. I might be a little bit conservative there. I might have been able to do with only 6 millimeters, maybe as little as 5. But if you take a look at the time-lapse video, it's probably definitely, I think, less than 5 would have been pushing it for some of the layers. And I stayed at 15 millimeters a minute the whole time. So very gentle lifting to try not to tear it apart. And I still have some wounding here, which is interesting, below that layer 87 line. And so the problem here doesn't have anything to do with curing. The curing is actually already over-cured at this layer. The problem here is the lifting stress. And we can see that this is the front, that's the back corner here, and I've always had trouble with these two back corners, especially on this side towards the edge, where there's a lot more lifting stress on this corner than there is on the front, where I don't really have these artifacts on the front. And so I'm going to there we go. Alright, so that's it for the build plate. And this guy, I can dry off this guy. This bucket is just the right size that it'll fit the build plate. I can fill it with water, but it'll still fit under the UV. This I got from Daiso for probably $1 or something. So lucky I still had it. It turned out to be pretty useless as a food container because the lid that it comes with warped in the dishwasher and was never airtight. So I had these sitting in my kitchen for a while, kind of useless, before I found that it was the perfect size for fitting the build plate, and still fitting in under the UV, whereas my other bins that I got are too big to fit under the UV light. So yeah, so dry this guy off. So this attachment layer is not extra. It is built into the bottom. These corner things are bits of extra that I added on to try to reinforce these corners from the lifting forces. The stock design is basically just a filleted square. I added these in post to try to add a little bit extra rigidity to these corners that I knew would be trouble, but apparently that just wasn't enough. And then, oh yeah, and then there's something extra, because you'll notice that there's this divot here. This is for the sprue bushing, and that is actually underneath here. And I'm gonna have to get out. Oh, interesting. There's of course some resin trapped in there. This might require another dunk. Because there's the attachment layer, so that comes over this, and then there's a support, and then the divot here. I don't know that I really want to go back into the. I guess I'll touch it quickly. Yeah, I should put my gloves back on for this, but impatient. In order to fit the sprue bushing, I'm probably going to have to sand that down quite a bit. So there's going to be some post-process work I'm going to have to do on this to make it usable for casting or for injection molding. So a bunch of sanding is going to be necessary here also, but still pretty good. This is of course just half. The core side, the cavity side, still need to print out the core side. We may try again to try to do it the proper way. Well, now that I've done it with this orientation, I'm going to need to probably print it exactly the same way for the other side, meaning probably with the exact same tray, so that the focus level will be the same, and that means it's going to create the exact same artifact here, because I'm going to have to use that damaged tray again before I resurface it, because I need to make sure the other half meets exactly. I might try to do something with external supports to try to keep this from happening. I'll have to see. And then much easier, the core side does not have one of these, does not have the sprue bushing. Alright. Well, so that's it. In theory, fill this with epoxy. Well, I will have to fix this hole here. I might just use, I could probably just use cyanoacrylate, crazy glue for that, just to patch it, and then I can fill in the epoxy. And the main thing is that this is the key surface that's going to meet, and this thing here is nice and flat, and this is the top part that the press is going to push down on, and this part here also is nice and flat, and then this part here for the sprue bushing I'm going to have to get flat through some through some sanding.